Okay, so a series connected circuit has the following properties. We have to calculate the value of the capacitance that will produce a quality factor of 50, find W1, W2, and B, and find the average power dissipated at the following uh, angular frequencies, and we take the Vm to be 100. Okay, so let's find the capacitance value. So we want a quality factor of 50. So what we can do is use the following formula. So we know Q is we know Q for a circuit in series is equal to omega O times the inductance all over the resistance, but it's also equal to 1 over WO times the capacitance times the resistance. So let's solve for this part first, and then we can work our way onto this part. So we're not really given omega O, or wait, are we? No. Okay, so let's solve for omega O first using this formula. So we know quality factor is 50. We're trying to search for omega O. You know the inductance is 25 millihenries, so 0.025 henries, and resistance is 4 ohms. So omega O, that is 8,000 radians per second. Now we can solve for C. So again, 50 is equal to 1 over omega O CR. Omega O is 8,000 times C times R, which is 4. And solving for C, you should get 6.25 times 10 to the power of minus 7 farads, which is 0.625 microfarads. Okay, so that's the first part done. The second part okay, so the second part we're asked to find W1, W2, and B. Okay, so to find W1 and W2, we will have to pretty much use kind of a long formula. So W1 is equal to minus R minus R over 2L plus the square root of R over 2L squared plus 1 over LC. And W2, which has to be greater than W1, will be equal to R over 2L plus the square root of R over 2L squared plus 1 over LC. Okay? So we know R, we know L, and we know C. So we just have to plug them all into the following. And after you do so, your W1 should be 7,920 radians per second. And your W2 should be 8,080 radians per second. And now we can calculate our bandwidth, which is just W2 over minus W1. So 880 minus 7,920, which is 160 radians per second. Alright, so we're almost done. Now we just need to find power. Okay, so to find the power, it's so for WO, which is a resonant frequency, it's equal to 1 over 2 Vm squared all over R. Okay, so it'll be 1 over 2 times 100 squared all over, what was the resistance again? Resistance was 4. And that should give you 1,250 watts. Now, for W1 and W2, it's actually the power for W1 will be equal to the power of WO over 2, because W1 and W2, they're the half power frequencies of WO. So it'll just be 1,250 all over 2, which gives you 625 watts. And this is also, and the same goes for W2.